Hi, welcome back to the Earth Science Classroom, looking at the East African Rift Valley system. So this is part 2 video, follows on from part 1. Part 1 was pretty much giving you the intro part, so where it was location-wise in terms of the planet, looking at what it is, a continental divergent plate boundary, a current rift system, a current spreading center of different ages, and we're looking at the actively spreading of a continent or continental plate in our lifetime, basically. And the part 2, this video is going to follow on and look at really how this is formed through tectonics, through plumes, and also hotspots. Okay, and looking at the ages and the areas in question, looking at the domes. All right, we'll explain what those are as well, and looking at different branches, or as I call them, the sections. And we've got the west and the east branches, and looking at also the the corresponding depression areas or low-lying areas in between, and discussing also the plateaus, which is the high elevation areas. All right, guys, join us now for the video. So what we have, let's look at the formation to start with. All right, so we're looking at a linear parallel valleys formed, well, basically, they're vertical, basically, vertical walls, and they are formed through downfaulting and faults. And faults, the type of is downfaulting. And these are all linked together to form basically a 6,400 kilometer or a 4,000 mile long chain, or continuous, continuous in terms of it's all linked, but sections and parts of discrete valleys all connected in a similar location, going basically north-south from kind of Mozambique in this area down here all the way up to the Middle East and Jordan up here. So you've got this huge extent of rifting system, and it was coined by Gregory in 1896. He also came back to Africa also in 1921. So Gregory was this English surveyor that had been commissioned by the government to go around different locations in the empire, Africa, Australia, India, for example, and he would survey and basically, do his thing with geology and start to identify different landforms. And he went to Africa twice, and Kenya in particular, and looked at this landform and coined the phrase a rift valley. So on the right hand side, you see the green lines are the outline of the land mass. So this bit here is the Indian Ocean. In Madagascar, here the island, you have the Somalian Peninsula right here, you have the Gulf of Aden, and you have the Red Sea right here, the Arabian Peninsula right here, and you have East Africa. Now the blue lines here outline the Great Lakes, and as you can see, the majority of them are located here. Now, in terms of sections or branches I mentioned before, you have the Western Branch, which is this section right here. Just outline it in black. So this section right here, okay, is the western section, and then this larger section in purple right here is the eastern section, which includes both the Ethiopian ridge at the top and the Kenyan ridge more southern. And you also have a section over here, which is called the southeastern section or southeastern branch right there, which is not as fully developed. Also, it is partly on the coastline, partly underwater. So it's not as clear cut as the ones more west inland. And we see the Great Lakes are kind of positioned right over the western branch of the rifting section. And this central one in the middle is Lake Victoria. It's a very large lake. And then Lake Turkana is the only real large lake, which is part of the eastern branch. And the eastern branch includes also the Ethiopian Rift or main Ethiopian Rift, which connects up to the Afar Triangle, the Afar Depression, and the Trill Point, which means that you have these three connecting plates that are all moving away from each other from this central location right here. So here is my triangle right there. Okay, that is the Afar Triple Point, or the Depression, or the thing. Now we're going to have videos on each part: the western branch, the eastern branch, the Afar Triple Point, and the Great Lakes as well. But just in terms of explaining this diagram. So from Gregory's observations, more and more experiments and observations, and recently seismic data and remote sensing, we can get an idea of how this formed. Now, there's also, I'm just going to clear this 1 second. There's two things I want you to look at on this map. Now, they're in pencil, okay? So I'm just going to outline it in black right now so you can see this area right here, all right? And this area right here. Now, these are basically contour lines of 1,000 meters elevation. And they outline the two domes. You have the Afar Dome in the north, and you have the East African Dome right here in the south. And it could also be called the Kenya Dome. There's also two smaller domes inside the East African, and these domes signify something very cool about the formation of this East African Rift Valley, and we'll get to that right now. Let's look at the hotspots. Look at plumes and hotspots. Now, plumes are, let's say you had the crust here, okay? You have the crust and lithosphere, and you have the asthenosphere right here, and then, you know, down here we have the 410 kilometer, 660 kilometer kind of discontinuity, and you have below it you have the mesosphere, mesosphere. Now, plume theory, there's various models that outline where plumes come from, where plumes originate, how deep do they start. They start in the asthenosphere, they start at the core mantle boundary. Some articles have stated that the African plume is a very large plume, as shown by the surface landforms that are created because of the plume. But also they suggest that it comes from the core mantle boundary. Now, this is still debated, but gives a good idea of how large these plumes are. Now, plumes are basically large volumes of magma or magmatic material or melt that is rising all at once, or as a singular unit, and it has like this, looks like this. So it's like singular unit, and it balloons out, comes up, okay, like a big elevator, a big tree, and it plumes out. It's called the plume head, okay. And you have the tail right here, which is feeding from deeper depths in the Earth's interior. So you have the movement of hot material coming through. Now, obviously, we still have convection currents working in the asthenosphere, like this. Oh, no, like this. All right. We still have convection currents, but plumes are something separate again, with the emergence and rising of material from deeper down. So this plume head and this plume is going to have an impact on the surface crust or plate. It is brittle, it is cold, and it's going to fracture. So this is part one, basically. It's the initiation of what's happening right beneath the East African Rift Valley. So the consequence of having a plume underneath the crustal plate is there'll be uplift. Initial uplift, raising of elevation, change of terrain, and what you get is this deformation, and you have this movement up of the crust. Now, because it's brittle, because it's cold, that level of elastic deformation, so elastic turns quickly into brittle because it's cold. Now, down here, where it's heated by the material, you're going to have some ductile, deformation right here. But the surface is not going to be ductile. It's going to be very brittle, and it's going to fracture and rupture. And what's going to happen is you'll have the pushing to the side, of this crust. You'll have this flexor response, from the crust, okay, and lithosphere, which is the plate. In this case, is the African plate or lithosphere. And it's going to basically, the plate has to go somewhere. It can't just go up all the time. It's going to have to start to be moved to the side. So once we have this uplift, we have created some plateaus. As I mentioned in a different video, plateaus, there's four main types of plateaus, and one of them is thermal expansion through plumes and uplift. So these plateaus, these raised areas, generally of flatter land, are shown on either side of this part of the crust and lithosphere, which is being actively spread apart because of the plume activity beneath it. Now, as it spreads and starts to move, you have tensile stress applied. When you have this kind of stress applied to the rock, what you get is faultings. Okay, faults from the fracture and ruptures that happen because the crust is brittle. So these faults are generally normal faults. Okay, they're generally normal faults, which look like this. But first, I'm going to show you what it looks like. So you're going to have all these faults, these dip-slip faults that are created because as the crust is being pushed either side, you're going to stretch the crust, break it, and then as it stretches, it starts to have some subsidence. So it starts to descend or lower or fall down. This is called downfaulting, as I mentioned earlier. It's called downfaulting, where the section of crust or lithosphere right above the plume is going to actually become thinner and stretched and start to have subsidence and fall down, and you're going to have this nice graben or graben formed through the stretching of plates. Now, I mentioned Wilson here from 1966. Wilson basically stated that there's a big cycle between the breakup of large supercontinents like Pangaea, and it gets broken up through various means, either plume activity or just general convection currents and tectonics, and they form and they break up these large continents into smaller pieces, and the pieces are either moved away or collided through various two types of margins, passive or active, and eventually, over a long period of time, that cycle will repeat itself and a large supercontinent will be formed through various stages of orogeny. But here we have the first or even second stage of Wilson's cycle, where the beginnings of a rift valley is being created, and the beginnings of a brand new, what's called proto-ocean, a brand new baby ocean. like the Red Sea, which we have in the northern part of this East African Rift Valley system, or a mature ocean like the Atlantic, which was created between Africa and North America when they started to divide and spread apart at the end of Pangaea at around 174 to 201 million years ago. So what we currently have with the East African Rift Valley is this long, extensive, linear, parallel, vertical cliffs and edges, basically either side are very large plateaus, and we have a graben formed here with some downfaulting and the plume coming up and causing this spreading to occur. Now, in different areas, so the average is around 60 to 160 kilometers, wide in width, and over 6,400 kilometers in length. By far the longest rift valley system in the world. There's one in Antarctica that comes close, there's one in Iceland, but pretty much this is the longest by far of rift valleys, and it's on land, and we can see it and do experiments on it pretty much all the time, which is fantastic. And I said various stages because the oldest part of rifting is around here in the Ethiopian Rift Valley and the Afar Depression, and the western area, the western branch is younger versus the eastern branch, which is the older one. We also have the Red Sea, which has been spreading and has various oceanic crust forming right there, which is basaltic versus continental. We can see different stages between the Red Sea and the Gulf of Aden right there. And it's just a great place to see this in action. Now, I'll get onto this in a different video, but as this is being created, this Rift Valley, there will be surges of dikes and channels where the magma is going to surge up as it's spreading through because it's thinner and being melted through. There's areas where obviously decompression melting, you get a lot of extrusive igneous voluminous magma and lava coming up through and filling these brand new rift valleys with very thick lava. And pretty much the eastern side is a lot of lava deposited on the surface, whereas western bank is not as much. But we'll get onto that in the future. And also this counts for the classic Mount Kilimanjaro and Mount Kenya, two beautiful complex mountain stratos that have multiple peaks, multiple mountain volcanoes within them, and are basically created because of this emergent of very large amounts of lava and magma coming out through the crust as this rift valley was forming. So as I drew on the map on the right-hand side, we have these outlined black areas of where elevation is 1,000 meters, a contour line. But it's outlined the two domes. Now, two domes are created because of the uplift and because of the or either side of the Rift Valley. These very large uplifted plateaus. They're not exactly flat, but dome-shaped, according to the name, dome shapes, and either side of the Rift Valley. The Afar Dome is in the north, okay, and contains the Afar Depression, okay, in the middle of it, where it sinks down to below 150 meters, okay, down to zero, obviously, at the coastline, and it is 1,500 meters in elevation on average. They're both over 1,000 kilometers wide, both domes. The Afar Dome includes the Ethiopian Plateau and the Somalian Plateau, as well as the Afar Depression. And these range in elevations, but they are a lot higher. So the Afar Dome is a lot taller, higher than the East African. East African does stretch further, but it's not as as high, not as tall. So this one is 1,200 meters on average elevation. Does include Lake Victoria. Has the the western branch, which is younger, versus the eastern branch, which is either side of it. And you can see like how large these domes are. The amount of magmatic material must be in these plumes underneath. So you have these two plumes, could be two heads on one connected tail, or two different plumes in the same location or similar location, both having their effect on this part of Africa. So maybe like the Turkana Depression, which is right here. Don't forget, a depression is a sunken area in the land. Depression that's around 600 meters, so it's not really like close to the coastline or very low elevation, like let's say the Afar Depression up here. But it's still going to be, nearly 1,000 or nearly half as high in elevation as the East African, or 1,000 meters less than the Afar. So you have that distinct reduction or decrease in elevation in between these two domes. And you have the Lake Turkana right there as well. So the formation is through plumes. There are two plumes working with these two domes, and they cause Rift Valley to basically go through stages of development based on the age, based on the amount of volume of lava coming up through, basaltic flood basalts coming through, looking at the width of it, the depth of this valley. And what you'll see that all this is connected to the domes and the plumes, and we'll get onto each section of the Rift Valley in later videos. So guys, thanks a lot for listening. Hope you enjoyed it, and see you later on.